Section 2.3 is patterns in nonlinear functions. Our goal is for a function that models a relationship between two quantities, interpret key features of graphs and tables in terms of the quantities, and sketch graphs showing key features. On page 110, we have the relationship in the solve it is an example of a nonlinear function. A nonlinear function is a function whose graph is not a line or part of a line. Just like linear functions, nonlinear functions can be represented using words, tables, equations, sets of ordered pairs, and graphs. So we have a concept summary of linear and nonlinear functions. Linear functions are a function whose graph is a non-vertical line or part of a non-vertical line. So here are some examples. We have a diagonal line going up from left to right. So it's got a positive slope and it's a solid line. We have a discrete just points descending from left to right, negative slope line, and then we have a horizontal line. Nonlinear functions are functions whose graph is not a line or part of a line. So we have a parabola, a cubic graph, an absolute value graph, which can also be discrete. Now we have example 1, the area A in square inches of a pizza is a function of its radius r in inches. Graph the function shown by the table. Is the function linear or nonlinear? We also have a second table with the weight in ounces and the cost, so we're going to do both. We're going to graph the weight versus the cost and the radius versus the area. If we look at the weight versus the cost, we have 2 and 80 cents, 4 and 1.60, 6 and 2.40, 8 and 3.20, 10 and $4. These form a perfectly straight line, so we say yes, this function is linear. For the radius in the area, we have 2 and 12.57, 4 and 50.27, 6 and 113.10, 8 and 201.06, and 10 and 314.16. Notice these are increasing, but it's increasing faster as we move up in the radius. So there's a bit of a curve here. It's not a perfectly straight line, so we would say this one is nonlinear. So for the weight and cost, we have linear. For the radius and area, we have nonlinear. The work for these separate pieces are on the next few slides. And then we have homework number 1. So I'd like you to figure out the cost C in dollars for pencils is a function of the number of pencils purchased N. The length of a pencil in inches is a function of the time T in seconds it has been sharpened. Graph the function shown by each table. Tell whether the function is linear or nonlinear. So we're looking at the number of pencils and the cost. So based on the number of pencils and the cost, you're going to graph the information in the table and decide whether it's linear or nonlinear.